We are going to look at today another problem about expected value of a random variable. Here is our problem. On Valentine's Day, the Quiet Nook restaurant offers a Lucky Lover special that could save couples money on the romantic dinner. When the waiter brings the check, he'll also bring four aces from a deck of cards. He'll shuffle them and lay them out face down on the table. The couple will then get to turn one card over. If it's a black ace, the couple will have to pay the full amount, but if it's the ace of heart, the waiter will give them a $20 Lucky Lovers discount. If they first turn over the ace of diamonds, they'll then get to turn over one of the remaining cards, earning a $10 discount for finding the ace of heart this time. If you are not familiar with cards, there are two different colors for the deck of cards. There is red and black. There are also four different designs: the clubs, the spade, the heart, and the diamond. There are 13 for each of the designs, and there are four aces, one for each design. So to summarize this problem, when the couple get their check, the waiter will bring with him four different cards. All of them are aces, one for each design. So the couple will have a chance to choose one of the four cards, and if they happen to choose the heart, then they will have a discount of $20. But if they happen to choose one of the two blacks, then they will not have any discount. If they choose a diamond, which is also red, they will have a second chance to open the remaining three. And if they find the heart, then they are going to get a $10 discount. Now, what is the problem that we are going to answer? Based on probability model for the size of the Lucky Lovers discounts the restaurant will award, what is the expected discount for the couple? So we are going to compute for the expected value of the random variable. The values of the random variable are the possible discount that a couple can get when eating in this restaurant. We are going to first identify the possible discounts, and then we are going to compute for the probability of each of these possible discounts. We are going to list now the different events as well as the discounts associated for each event. For example, it is possible for the couple to choose the ace of heart, in which case they will have a discount of $20. But if they happen to pick the ace of diamond, then they will have a second chance of opening one of the three remaining cards, and if they happen to pick the ace of heart, then they will have a discount of $10. Now, if they happen to pick one of the two black cards, they are not going to get any discount. However, if they open also a ace of diamond and then followed by a black heart, they are not also going to get any discount. In other words, the discount will be zero. Now we are going to compute for the probability of each of these events, which is also going to be the probability for each of these possible discounts. We are now going to simulate the situation when a couple is given a chance to open the cards. I'm going to use A sub H as the ace of hearts, A sub D as the ace of diamonds, A sub C as the ace of clubs, and A sub S as the ace of spades. Now, when the couple happen to open the ace of heart, they are not going to open any more of the three remaining cards because they are going to be given right away a discount of $20. But for the purpose of listing all possible scenarios, I'm going to write here the cases where the couple are given a chance to open two cards one at a time. For example, A sub H, A sub D means the couple pick the ace of heart the first time and A sub D the second time. Again, they are not supposed to open a card the second time when they already have a heart the first time. But it's also possible that they will have A sub H and then followed by A sub C, A sub H followed by A sub S. In each of these three cases, the couple will receive a $20 discount. It's also possible, however, that they happen to pick A sub D, the ace of diamond, and then followed by A sub H, the ace of heart, in which case they are going to receive a $10 discount. But if they are going to pick A sub D as the first pick and then A sub C, which is a black card, the second time, then they are not going to be given any discount. It's also possible that it's A sub D for the first pick and then A sub S for the second pick. If they are going to pick one of the black cards, say for example the club as the first pick, they are not going to open any more cards because right away they are not going to receive any discount. But again, for listing purposes, I'm going to write all the possible cases. So we have A sub C and then followed by A sub D. A sub C followed by A sub H, A sub C followed by A sub S, A sub S and A sub D, A sub S and then A sub H, and then A sub S and then A sub C. These are all the different situations when the couple is given two chances to open any of the four cards without replacement. Let's look at the case where the couple will receive a $20 discount, and that will happen when you have A sub H as the first pick. And there are 3 cases among the 12, so the probability is 3 out of 12. And if you are going to simplify that, you're going to get 1 over 4. Now for the $10 discount, the couple will have to open the Ace of Diamond the first time and then Ace of Heart the second time. And that is only one case among the 12. So the probability is 1 over 12. Now for the zero discount, the couple will have to open a black card the first time or a diamond for the first time and then a black in the second chance. So there are a total of 8 out of 12. That reduces to 2/3. So this will become the probability for each of the discounts. We are now going to look at our table and populate these probabilities. So here's again our table. The probability, therefore, for having a discount of $20 is 1 over 4. And the probability of having a discount of $10 is 1 over 12. And the probability of having zero discount is 2 over 3. We can also get these numbers without actually writing all the possible cases, all the possible results when we have 4 cards. We can just look at the different probabilities for each event and still be able to identify the probability for all the events that is given in this table. Let's look at them again. We are going to compute for the probability of each of the events without simulation. Let's consider the event for the Ace of Heart. There are only 4 cards in the table and only one of them is an Ace of Heart. So therefore, the probability of picking an Ace of Heart is 1/4. And therefore, the probability of having a $20 discount is 1/4. Now, for the event of picking an Ace of Diamond for the first pick, followed by an Ace of Heart in the second pick, we are going to consider the 2 different independent events, the Ace of Heart for the first pick and then Ace of Heart in the second pick. For the first pick, there are 4 cards in the table and only one of them is a diamond. So the probability of picking an Ace of Diamond for the first pick is 1/4. Now, if we have already the Ace of Diamond on hand, there are only 3 cards remaining on the table, and only one of them is an Ace of Heart. So the probability of picking an Ace of Heart among the 3 remaining cards is 1/3. These 2 events are independent, so we can multiply them, and therefore the probability of having an Ace of Diamond in the first pick followed by an Ace of Heart in the second pick is 1 over 12. And therefore, the probability of having a $10 discount is 1 over 12. Now, for the third event, we have 2 different cases. Case 1 is when we happen to pick a black ace, the first pick. There are 4 cards, and among the 4, there are only 2 which are black aces. So therefore, the probability of picking a black ace is 1/2 or 2/4. The other case is when we happen to pick an Ace of Diamond in the first pick and then followed by a black ace in the second pick. There's only 1 among 4 as Ace of Diamond, and if we pretend that we already have the Ace of Diamond, there are 2 black aces remaining among the 3 cards. So therefore, the probability of picking a black among the 3 is 2/3. We are going to multiply these two, and we are going to get 2 over 12 for the second case. We are now going to add the result for the first case and then the result of the second case. This together will be 2 over 3. So the probability, therefore, of picking a black ace for the first pick, or picking an ace of diamond for the first pick followed by a black ace in the second pick, is 2/3. This is now going to be the probability for zero discount. Let's look at again our table. So here, our table shows the different discounts. For $20, it's 1/4, and the probability for $10 is 1 over 12, and the probability for zero discount is 2/3. We are going to compute for the expected value of the random variable, and so therefore, we just have to multiply 20 times its probability, 10 times its probability, 0 times its probability, and add all of them together. So we have 5 times 10 over 12, and finally we have 5.83. This means $5.83. So therefore, for couples dining in this restaurant, they can expect an average discount of $5.83. This is the answer to the question. Thank you.